Okay, saya Muhammad AIMAN. Saya akan present introduction pada projek digital elektronik ni. Okay, so nama tajuk adalah dual axis solar tracking system with sensor. So about this ni. So solar is the fastest growing means of renewable energy. So this project is designed to implement using simple dual axis solar tracking system. In order to maximize energy generation from the sun, it is necessary to introduce solar tracking system into solar power system. A dual axis tracker can increase energy by tracking sun rays from switching solar panel in various directions. This solar panel can rotate in all directions. So this dual axis solar tracker project can also be used to sense weather, and it will display on LCD. This system is powered by Arduino or PIC and consists of servo motor, rain drop sensor, temperature, emulator sensor, and LCD. Okay, so the objective of this project is to maximize the utility of the solar, to minimize human workforce and make it smart. So finally, to harvest sunlight as maximum as possible.
Hello, my name is Ahmad Mustapha bin Muhammad. My group has done a project about dual axis solar tracking system with weather sensor. For my slide, I want to show about what tool that my group use, and what is hardware that my group use. Okay, for the tools, we use first wire stripper or cutter. Second is screwdrivers. Third is rubber feet. Rubber feet is used to make sure the circuit don't vibrate or move. Rubber feet is attached under the circuit. Next is cable wrap or twist ties. Cable wrap is used to make sure the cable can be organized and optimizing the space. Okay, for the hardware, first, we use Arduino Uno. Arduino Uno is a microcontroller board based on the microchip at Mega 328P and developed by Arduino. This board is equipped with set of digital and analog input or output pin that may be interfaced to various expansion boards and other circuits. Next is Arduino Sensor Shield. Arduino Sensor Shield is a low-cost board that allows you to connect a range of sensors to your Arduino using easy-to-attach jumper cables. Next is gear servo. Servo gear is a unit that reduces the speed of a motor. It transmits the flow of force in different ways, depending on how its gearing and gear unit stage are arranged and operate. Servo gear unit serve as converter of torque and speed. Next is terminal block. Terminal block is a modular insulated block that can secure two or more wires together. It has many pin, 5, 2, 3. Next is a resistor. As you know, resistor is a electrical component uh, that can use for reduce current flow, adjust signal level to divert voltage and others. Next is photoresistor of LDR. LDR is a light dependent resistor. Is an electronic component that is sensitive to light. When light falls upon it, then the resistance change. Working principle of LDR is photoconductivity. The resistance decrease with increase in incandescent light intensity. Next is JST connector cable. JST is Japan solderless terminal. Its connector are electrical connector manufactured to the design standard originally. Developed by JST Manufacturing Company. Next is a jumper wire. As you know, jumper wire, also known as jumper wire or jump wire, is an electrical wire which have a connector or pin at each end. Next is solar cell. Solar cell is an electrical device that converts the energy of light directly into electricity by the photovoltaic effect, which is a physical and chemical phenomenon. Photovoltaic effect, the meaning is the generation of voltage and current in material upon exposure to light. That is the meaning of photovoltaic effect. Next is a LED voltmeter. Voltmeter is an instrument used for measuring electric potential difference between 2 points in an electric circuit. Uh, and in this circuit, we use digital voltmeter. It can measure unknown input by converting voltage to digital value and display it in numeric form. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NAJMI. So today I'm going to explain about core component for our project, which is dual-axis solar tracking system with weather sensor. So this is the core component. The first one is Arduino Uno. The second one is photocell. The third one is servo motor. So first, we take a look at Arduino Uno. So this is the picture of the Arduino Uno. So for Arduino Uno is a microcontroller board based on the ATmega 328B from the datasheet. It has 14 digital output pins, which is 6 can be used as PWM outputs. It also have 6 analog inputs, 16 MHz ceramic resonator, USB connection, power jack, ICSP header and reset button. It also can simply connect it to computer with a USB cable or power it with a AC to DC adapter. So the second one is photocell. This is the picture of photocell. For photocell is a light sensor that generates output signal. So we use it as a output that indicating the intensity of light by measuring the radiant of energy. So secondly, photocell or light sensor is a passive device, which is that this device is convert the light energy, whether visible or in the infrared parts of the spectrum, into an electrical signal output. It's also commonly known as photoelectric device or photosensor because it converts the light energy photons into the electricity, which is electrons. So that's for photocell. Then the last one is servo motor. So this is servo motor, the picture of servo motor. Servo motor is a type of motor that can rotate something with a great precision. Normally this servo motor consists of control circuit that provide feedback on the current position of the motor shaft. The feedback also allow the servo motor to rotate with great precision. If you want to rotate an object at specific angles or distance, we use this servo motor. It also can be named by by the power that we use. If we use the the DC power supply, that is so then it is called DC servo motor. If we use AC power motor, AC for the power motor, so then it is called AC servo motor. So that's all from me. Thank you.
Okay, so my name is National HAKIMI ZAHILAL. I'm from class PET S1/1. So today, in this assignment, I would like to present about the Project Digital Dual Axis Solar Tracking System with Radio Sensor. So this is my group members: Muhammad AIMAN bin MOKHTAR, Ahmad Mustapha bin Muhammad, ALIFF NAJMI bin AFIFFUDin. So I will explain a bit about the circuit, and the rest will be my members represent about the intro and the coding and the hardware component for this project. So I will explain about the circuit. So for the circuit introduction, we use circuit for this project, which is simulation using Arduino and simulation using logic gates. Photocell encoding Arduino is very important in this project because it can run the project smoothly. For the logic gates, we use the basic gates to make sure it can run properly. So we use two circuit which is simulation using Arduino, and one more is simulation using logic gates. So I will explain about the simulation using Arduino. So we have 4 photocell and 4 resistor, 2 motors and 1 ground. So we use of course we use the Arduino to run the project. So basically the photocell will connect to the resistor, and the resistor will be connected to the Arduino. So and for the input we have for the output we have 2 motors and 1 ground, which is for the to make the motor uh, run smoothly. So uh, by using this circuit, we can know that the dual axis solar tracking system uh, will be will be much better than the uh, uh, alone axis solar tracking system. So the coding will be used on this assignment. We run the project and we know that the project will run smoothly. So that's all for the simulation using Arduino, and I'll explain about the and next one I will explain about the simulation using logic gates. So by these logic gates we have we have um, 3 and 4 and 4 or and 12 AND gates. So and 4 NOT gates. So we use the sensor, one IC which is L293D, and 2 motor for the output, and the logic toggle to make the truth table. So I will run the project. Wait. Okay, so the project has been run. So we got here the motor is functioning well. We know that when the sensor is reacting to the motor, it's reacting to the weather, the motor will be run smoothly. So we know that in this lab we use the logic toggle for the to measure the AND gate to measure the AND gate for the input and output uh, for the motor to run properly. And that's all, and thank